Hi there. As par for the course these days, I forgot to hit record on the meeting this morning, on the live class this morning, so I basically did 3 problems on the whiteboard this morning. I'm going to do the 3 problems right now, the same as I did this morning, and hopefully it helps. I think when I was done, I didn't hear back from anybody, but I've got a hunch what I was doing on the whiteboard probably makes things a little bit easier for you. So I'm going to look at one of the questions from Tuesday's homework before I do yesterday's homework. Now, I've already done a couple of Tuesday's homework questions, but I really want to do this again because I've got a slightly different approach that I was thinking about this morning before the morning class, and I think it seems to look like I think it's easier to use. So, question 9 from page 219 has a chemical called ammonium, NH4, nitrate, NO3. Remember, ammonium is a +1 ion, nitrate's a -1 ion, so the ones come down. And when it decomposes into 2 chemicals. One is dinitrogen monoxide. It's a molecular compound, so a nonmetal and a nonmetal. So notice that I need to use the monodies, so it's dinitrogen monoxide plus 2 dihydrogen monoxides, or 2 waters. Now, the question says, if I start with 3.67 grams of ammonium nitrate, how many grams of water are we going to get? All right, so it's a decomposition reaction. I know that the mass of the products will equal to the mass of 3.67, but I don't care about the N2O. The question doesn't mention N2O. It doesn't tell me anything about, and it's got nothing to do. I'm looking at how much water is going to be made in this reaction. Now, to do this, we're going to do like we did on Tuesday, which I'm going to use the mass to determine the number of moles here with a mole ratio to find the number of moles here, and then use the number of moles here to calculate the mass. Okay, so there's my flow. Now you're going to see as I work through this today, I'm going to do it slightly differently. So I'm going to follow the same first step, molar mass and molar mass. Molar mass for water is 16 for oxygen and 2 hydrogens, makes 18.02 grams per mole. There's my molar mass for water. Not 2 waters, molar mass, 1 mole. Okay, so it's 1 oxygen and 2 hydrogens, 1 H2O. And on the left side, I've got NH4NO3, so I've got 2 nitrogens, which is 28, 3 oxygens, which is 48, so 28 and 48 is 56, 76, plus 4 hydrogens makes it 80, and all the 0.01s, 80.08 grams per mole is my molar mass, or 80.06 grams per mole is my molar mass for ammonium nitrate. Now, I want to start off here by calculating my number of moles, mass over molar mass, 3.67 grams divided by 80.06 grams per mole, and I'm getting the number of moles is equal to 0.0458 moles. So I now know my number of moles of ammonium nitrate, and I'm going to use the little n here to calculate the little n on this side. But like I said earlier, I'm going to do this a little different than I was doing before. So here's what's different. I'm going to do a mole ratio. I'm going to do a mole ratio of my unknown number of moles, which is water, to my known number of moles, which is ammonium nitrate. So a ratio is a fraction. It can be set up as a fraction. So I'm going to take my number of moles of unknown here, which is what I'm trying to figure out, how many moles of water. Ratio is divided by the number of moles of known, which in this case is the ammonium nitrate. And I'm going to say that that's equal to the same thing that I've already got there, number of moles of water over the number of moles of ammonium nitrate. Now you think, well, that's got to be equal, because what I've got on the left side of my equal sign is the same as what's on the right side of the equal sign. So they've got to be equal, right? Well, what's going to be different is the things that I'm going to put on this side are the numbers from the balanced chemical equation here, And the things that are going to go on the left side of the equal sign are the numbers that are actually in the question itself. Right? So again, remember, I'm trying to find number of moles, little n, so I can solve for my missing mass. So let's just scroll this up a little bit, and I'm going to put in the numbers that I know. Well, I don't know my number of moles of water, right? That's my unknown in the question right now, because that's what I'm trying to solve in order to do this calculation here. But I do know the number of moles of ammonium nitrate is 0.0458. So in the denominator, I can put 0.0458. On the right side of my equal sign, I'm going to put the number of moles as we see it in the balanced chemical equation. So in the balanced chemical equation, my number of moles of water is 2, and my number of moles of ammonium nitrate is 1. 2 waters, 1 ammonium nitrate. So if I do my mole ratio from the balanced equation, I have for the number of moles of water 2, number of moles of ammonium nitrate 1. Okay, so look at that. So now I'm going to take my number of moles of ammonium nitrate from here and move it up beside the 2, and I'm left with, on this side, number of moles of water, which is what I'm trying to calculate, is equal to 2 times 0.0458 divided by 1. So my number of moles of water is going to be equal to 0.0916 moles. Right? 0.0458 times 2 is 0.0916 divided by 1. So now I can take that number of moles and move it up to here and say, well, I now know that my number of moles is 0.0916. And now I know my little n and I know my molar mass. I know my little n, I know my molar mass. I can substitute them in here and solve for my missing mass. Okay, so mass is equal to 0.0916 times the molar mass for water, 18.02 grams per mole, and I get an answer which is 1.65 grams. Mass of water. So that tells me that when 3.67 grams of ammonium nitrate decomposes, one reactant makes 2 products, I get 1.65 grams of water, and I'm guessing I would get 2.02 grams of N2O, the missing mass. Okay, but again, we're not asked about that. All I'm asked is how much water. Okay, so let's go from there. Okay, this morning I went to question number 12 from the homework on page 223. Excuse me. Question 12 says ammonia, important fertilizers produced from nitrogen and hydrogen using this formula here. Nitrogen. Notice that I'm going to leave myself lots of room on my page here. Two ammonias. Ammonia is NH3. Okay, so N2 plus, it should be 3 H2s makes 2 NH3. Okay. Notice from the last question that everything on this side of the equation came from my balanced equation. If my balanced equation, way up here, wasn't balanced right, wasn't balanced at all, or wasn't balanced right, then this step here goes wrong, then the little n here goes wrong, and then my mass here is wrong too. So everything from this point on all becomes wrong because my balanced equation wasn't right. Which is why we start balancing equations in grade 10, right? Getting used to how to do balanced equations. Okay, so in question 12, it gives us a mass of nitrogen gas. Mass is 8.20 grams. And it gives me a mass of hydrogen gas, 15.0 grams. And the question is, how much ammonia are we going to get? You think, well, that's easy. 8 plus 15 is 23, right? The law of conservation of mass tells me that the mass of the reactants has to equal the mass of the products. Okay? The problem is, not all of the reactants are going to get used. One of them is in excess. So if only, let's make up a number here, if only 5 grams of this get used and 10 are left over at the end, I should get 5 and 8, I should get 13 grams of product. If only 1 gram of this gets used and all 15 gets used up, I'll have 7 grams of this left over and I'll get 16 grams of product. So before I can do anything, I've got to figure out which one is going to run out, which one is going to be my limiting reagent. Now to do that, I'm going to start following my steps. Number 1, make sure the reaction is balanced. Okay, I'm seeing 2 nitrogens on this side, 2 nitrogens here, 6 hydrogens on the right, and 6 hydrogens on the right. Okay, on the left. So everything is balanced, and I'm going to follow my steps. Calculate my molar mass for each. Molar mass for nitrogen is 28.02 grams per mole. I'm just going to ignore that. Grams per mole. My molar mass for hydrogen is the mass for H2. Well, each H is 1.01, so a molar mass is going to be 2.02. Hang on. And now I need my molar mass for NH3. My molar mass is going to be the mass of nitrogen, 1401, plus 3 hydrogens at 1.01, so I get 17.04 grams per mole. Okay, so there's my next step, was calculating the molar mass for everything. Okay, step 2. Step 3 is to determine my number of moles of nitrogen and my number of moles for hydrogen. Number of moles, remember, is equal to mass divided by molar mass, which here is going to be 8.20 divided by 28.02. And over here, it's going to be mass 15.0 divided by the molar mass of 2.02. Okay, on my calculator, I'm going to get my masses, my numbers of moles. So I'm going to get 0.293 moles of nitrogen were in the system, in the test tube, in the beaker, whatever it is. And I've got 7.45 moles of hydrogen gas. Okay, so now I know what I put into the beaker. N. So I know my number of moles of both. Now I need to figure out which one did I put too much of. Because the one that's the lower amount is the one that's going to run out first. When it runs out, I can't make any more product. So I need to know how much, which one is going to be the limiting and which one is the one that's in excess. To calculate that, I need to take the number of moles, 0.293, and divide it by the number in the balanced equation here, which is 1. And I need to do the same thing here. I need to take my number of moles, and I need to divide it by the number of moles in the balanced equation, which is 3. When I do this one, I'm going to get 2.47, 2.48. Okay, so once I know these two numbers, I now have the information that I need to move forward. I know which one's going to run out. The lower one is going to run out. It's going to be called my limiting reagent. And the one that I have too much of is the high one. This one is in excess. Right? There's too much there. Again, when I talk about somebody who does something to excess, I say they're doing too much of it. So in this case, there is excess of the hydrogen and limiting amounts of N2. So which one decides how much product I'm going to get is the one that's lower here. So this is the number of moles here that decides how many moles of ammonia I'm going to get. Everything that's on this side, right, has nothing more to do with the question, because even though it's there, it's not really helping me to decide how much product I'm going to get. Okay, so everything that's in my side here was used only to determine what my limiting and excess reagents are. Now I'm going to do my mole ratios. So from the original question, my unknown is here. My unknown is here, which is the number of moles of ammonia, and my known is my number of moles of N2 gas here. So I'm going to set up a mole ratio that has number of moles of ammonia on top and number of moles of N2 on the bottom. Again, remember, this is my unknown, this is my known. This is what I'm trying to solve for. It's what's on top. I'm going to, on the other side here, I'm going to put number of moles of ammonia. And on the bottom, I'm going to put number of moles of N2. Now remember, everything that's on this side of the equation comes from the balanced equation. The numbers on this side of the equation are from the question that I'm solving right now. Right? I can always give you a balanced equation. It doesn't mean that you're having to solve anything. I just maybe ask you to balance it, right? And you can get those numbers that we just had, right? These numbers here. But now I want to know how much product I'm making. So I'm going to scroll this up a little bit higher, and I know that my number of moles of ammonia is my unknown. My number of moles of nitrogen gas is 0.293 moles. On this side, I've got ammonia over N2 gas from the balanced equation. So ammonia and N2. The ammonia I can see is 2. The N2 is a 1. Two ammonias, 1 nitrogen. 2 ammonias, 1 nitrogen. Right? Remember, ammonia on top, nitrogen on the bottom. Now to solve for my number of moles of ammonia, I'm going to take my 0.293 up beside the 2. I'm going to multiply it by 2, divide it by 1, and I will get my number of moles of ammonia equals 0.586 moles. Okay. Now I know my number of moles on this side. I can use that number of moles up here. Okay, my number of moles was 0.586. Number of moles of ammonia, 0.586 moles. And now I can calculate my mass because it's equal to number of moles times molar mass. And I have both of those, number of moles and molar mass. So my mass of NH3 that's going to be made is going to be 0.586, number of moles, times the molar mass, 17.04. Right, and I'll get my final answer. And my answer comes out to be 9.99 grams. 9.99 grams. Okay, so now you can see that if I start with a certain number of grams, hang on, I'll be right back. If I was in my classroom at school, this wouldn't happen. I wouldn't have people coming to my door, people calling on the phone, dogs barking. But anyway, here we are. Okay, so there's the answer for question 12 on page 223. Okay, I did one more question this morning, and I want to do it right now. And hopefully you'll find it helpful. Same thing. All these questions are the same thing. I'm just changing the chemicals. So question 10. on page 225 has zinc, metal, reacting with 2 manganese dioxides plus an H2O. 3 reactants here. This is a big question, a big reaction I should say, making zinc hydroxide plus an Mn2O3. Mn2O3. So there's my whole question, and the question tells me that the mass of zinc that we're going to use, come on, is 25 grams. My mass of manganese dioxide is 30 grams. I'm not told about water, so I'm not going to worry about the water. It says assume that there is excess H2O in the question. And then the question says how much zinc hydroxide are we going to make? So there's our question. It's exactly the same thing. Notice that I am ignoring this and ignoring this, right? They have nothing to do with the question. I'm going to follow my same steps. I'm going to start with my molar mass for zinc, which is 65.41 on my periodic table. My molar mass for MnO2, manganese is 54.94 plus 2 oxygens, so it gives it a total mass of 86.94. Again, remember molar mass is exactly that. It's the mass of 1 mole, not the mass of 2 moles, not 2 Mns and 4 O2s. I want 1 mole. It's 1 Mn and 2 O2s. Right, so there's my 86.94. (54) and 32 is 86, yes. And then my molar mass for my product, zinc hydroxide, ZnOH2. Zinc we know is 65.41 plus OH times 2. So I've got (99.43). It's my molar mass for zinc hydroxide. 1734 and 65 makes 99. Okay, now I'm going to have to figure out how many moles do I have here, how many moles do I have here, because ultimately I need to know how many moles I have here, because I'm going to try and solve for my mass, right, which is number of moles times molar mass. So I need to know my number of moles here, which right now is missing. So to do that, I've got to figure out which of the reactants is going to run out first. So let's start by calculating the moles. Number of moles, mass divided by molar mass, right, which is 25 grams, divided by the molar mass of 65.41 grams per mole. For the MnO2, I've got 30 grams, divided by the molar mass of 86.94. So I can calculate my number of moles, 0.382. Moles. And for my MnO2, I have 30 grams divided by 86.94. I'm getting 0.345 moles. Okay, once I've calculated my number of moles, I need to draw that line, because I'm now just going to take away from the question. I want to look at which one's going to run out. So to figure that out, I'm going to take my number of moles, I'm going to divide it by the number from the balanced chemical reaction. I had a 1 here for zinc, so I'm going to put 1 down here. On the manganese dioxide side, I've got 0.345 moles. And I need to divide it by the number from the balanced equation, which is 2. Okay, so those are my two numbers there that I need to look at to decide which one of these two chemicals, the zinc or the MnO2, is going to run out. And I can see that the lower one is this one. So this one's limiting, this one's excess. This one is limiting, this one is excess. The one that's in excess, well, I don't need to think about it anymore because it's not going to tell me anything about how much product I'm going to get. What's going to tell me about the amount of product is the one that's going to run out, because it's the one that will decide how much product I'm going to get. So now that I've got that far, now I've got to do my mole ratio. Now, to do the mole ratio, I need to look at the two compounds that I'm now looking at in the question. One is the zinc hydroxide, my unknown. The other one is the manganese dioxide, which is the one that's going to tell me how much zinc hydroxide I'm going to make. So I'm going to set my mole ratio up with zinc hydroxide on the top because it's my unknown, and manganese dioxide on the bottom. So let's set this up here. Number of moles of zinc hydroxide goes on top. Number of moles of manganese dioxide goes on the bottom. I'm going to set it up exactly the same. Number of moles of zinc hydroxide on top, and number of moles of manganese dioxide on the bottom. Again, remember, this side here comes from the balanced equation. This side here is about my question that I'm solving. So, if I just scroll up a little bit here, my number of moles of zinc hydroxide is unknown. Okay, that's what I'm trying to solve here, right? It's the number of moles of zinc hydroxide. That's my unknown. What's known is my number of moles of MnO2. It's 0.345 moles. So let's go back here. So my number of moles of MnO2 is 0.345 moles. And then on the right side, I've got zinc hydroxide and manganese dioxide. But remember, this side here comes from the balanced equation. So if I go back up, I look for zinc hydroxide, which has 1 in the balanced equation, and manganese dioxide, which has a 2 in my balanced equation. So zinc hydroxide is 1, manganese dioxide is 2. Zinc hydroxide is 1, manganese dioxide is 2. So now to solve for my number of moles of zinc hydroxide, I'm going to take my 0.345 here, up beside the 1, and now to solve for my number of moles of zinc hydroxide, it's going to be 1 times 0.345 divided by 2. Number of moles of zinc hydroxide equals 0.345 times 1 divided by 2. And my answer comes out to be 0.173 moles. So that's my number of moles of zinc hydroxide, 0.173 moles. Let's go back up here. So all the way back to the beginning, number of moles of zinc hydroxide, 0.173 moles. Right. Now that I know the number of moles here and the molar mass, I can solve for my missing answer for the question, which is how much zinc hydroxide are we going to make? It's going to be number of moles, 0.173, times the molar mass, 99.43, and I'm going to get a final answer of 17.1 grams. Okay, so the question says, when you put 25 grams of zinc and 30 grams of MnO2 into that flask, how much zinc hydroxide are you going to make? I'm going to make 17.1 grams of zinc hydroxide. Okay, all these questions are the same, right? So set them up, balance your equation, calculate your molar masses, right? Balance your equation, calculate your molar masses, calculate your number of moles, figure out draw your line across, figure out which one is limiting, right? Used by dividing the number of moles by the number in the balanced equation, decide which one's going to run out first, right? The excess one, to put a scratch through it so you don't have to see it anymore. Then set up your mole ratio with your unknown number of moles and your known number of moles. From the question and from the balanced equation, right? Solve for little n, right? Using your mole ratios, and then solve for your mass. Every question is the same. Now, this morning when I was doing this, I left you with two more questions that are in the back of the book, I believe. I can't remember which ones now. I can't remember. Question 26 and question 28. In the chapter review on page 240. Okay, so there's a little more practice for you doing limiting reagent questions. I think 25 is just a mole ratio question, so you could do 25. It's be fast and easy. Right, if you want to do 25 for just a bit of extra practice using your mole ratios. Okay, so I'm going to stop there. On Monday, so just to go back to, I don't know how long this is going to take to load, but on Monday, tomorrow, Friday, we're going to finish up. That's not what I wanted. We're going to finish up Chapter 6, which is one section, and I will do a note for that probably right now, actually. And then on Monday, tomorrow, I will assign a review for Chapter 6. Monday, we will do the review for Chapter 6, so I will have an online class on Monday next week, not Tuesday, but Monday. And then Tuesday, we'll have our test for Chapter 6. And then on Wednesday, I'm actually going to have a day where we're going to talk about the ISU and get you a little bit ready for the ISU test, which comes the following week on the environmental chemistry stuff. All right, so if you look at our calendar, you should see that here we are today with our live class. Whoops. So tomorrow I'm going to finish Chapter 6. Tomorrow is May 1st. We're getting very close to the end quickly. Okay, so there's May 1st tomorrow. Review class for Chapter 6. We're going to have a live class here. We'll have our test for Chapter 6 here. We'll have the ISU session here, because our ISU is due here on the 12th. A few of you have already handed it in, which I'm really happy to see. I will not take your ISUs after the 12th. Right? Every other assignment, careers, STSEs, anything else that we've done, I don't care when it comes in, but the ISU assignment is due on the 12th. All right, you've had it since February the 15th or so. It's now May 12th, so that's about 10 weeks or more that we've had the ISU, so you should be done that one. Try not to get behind with your career or STSC assignments because, again, some of you handed in all the career and all the SCSC assignments, which again is awesome, so you don't have to worry about it as we move further into finishing up May, and then a couple of weeks in June, and we're done. Whatever exams are going to look like, whether we'll have exams or not, I'm thinking we probably won't, but there may be culminating tasks that we don't normally have that you'll be working on your own instead of doing the exam. So I really don't know what June's going to look like yet, but try and stay on top of your assignments for all of your classes so that when your final few weeks of semester come, you've got everything done except whatever final evaluations there are. So we're going to start our new unit next week on Thursday. Again, I haven't decided yet if I'm doing organic chemistry or electrochemistry, but we'll know as we get closer to the time.